Okay, so we're going to prove the converse of the alternate interior angles theorem, which states if two lines cut by transversal have congruent alternate interior angles, then the two lines must be parallel. So if we have 4 is congruent to 5 and 3 is congruent to 6, then P and Q must be parallel. So if we can prove this, then we know the alternate interior angles theorem is an if and only if statement, which would be really useful to us. So let's go ahead and get started on this proof. So proof. Okay, so we're going to, of course, assume angle 4 is congruent to angle 5, and angle 3 is congruent to angle 6, right? Okay, next we're going to use the vertical angle theorem. So by vertical angle theorem, I know that angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Let's see. Angle 6 is congruent to angle 8. And angle 7 is congruent to angle 5, right? 1's congruent to 3, 2 is congruent to 4, 6 is congruent to 8, and 7 is congruent to 5, right? Because they're vertical angles. So now, all I'm going to use is these two things together, right? These two statements together in order to get what I need, okay? So the strategy is, if I can show that all the corresponding angles are congruent, then by the corresponding angles postulate, I know that these two lines are parallel, okay? So let's see what I can do. So I know that angle 1 is congruent to angle 3, right? Angle 1 is congruent to angle 3, and angle 3 is congruent to angle 6. So this implies that angle 1 is congruent to angle 6. And notice that is one of the pairs of the corresponding angles, right? So now I'm a fourth of the way done. I also know that angle 2 is congruent to angle 4, and angle 4 is congruent to angle 5. So this implies that angle, let's see, 2 is congruent to angle 5, right? So now that's another one. I'm going to split it off here so I can have some room. I know that angle 4 is congruent to angle 5. And angle 5 is congruent to angle 7, right? So this implies that angle 4 is congruent to angle 7, right? So now that's one more. And then the last one, I think, is 3 and 8, right? I need to show that 3 is congruent to 8. Well, I know that angle 3 is congruent to angle 6, and angle 6 is congruent to angle 8, right? So that means that angle 3 is congruent to angle 8. So notice I have all the corresponding angles congruent to each other. 1 is congruent to 6, 2 is congruent to 5, 3 is congruent to 8. Where do I have that? 3 is congruent to 8 here. And 4 is congruent to 7, right? So yeah, 1, 6, 4, 7, 3, 8, and 2, 5. Yep. Okay. So now I can use the corresponding angles postulate. So by cap, right? So cap tells me that, let's see, if I have angle 1 is congruent to angle 6, angle 2 is congruent to angle 5, angle 4 is congruent to angle 7, and angle 3 is congruent to angle 8, then I know this is a biconditional statement, then I know that P is parallel to Q, right? Because that's how we label them, line P and line Q. So since I know the corresponding angles are congruent, I know that these two lines are parallel, and that is the proof.